I've got small letters, but give you a problem. Gave you the simplex tableau after the first pivot step. It asks you to do the next pivot step in question 8. Okay, so I've done that. We got this. Is this the final solution? Or the optimal solution? It is why.
Non-infinite values.
Right. 0, 0, positive, positive. All good, happy. Right, so I realized after last week's lecture that we might have got lost a little bit in translation what we were actually doing. I mean, there was a lot of small steps and we were deriving something, but maybe the kind of holistic point of view of why we want to know all these things got lost. So the reason we want to know all these things is because we want to understand the simplex tableau for several reasons. Okay, so one of them is this exercise, exercise B, which asks you, if I give you a basis, x1, x2, and I tell you this is the optimal basis, can you write the whole tableau without having to pivot? It can be useful in some situations. Yeah, it can be useful in some situations, and we'll see that. Okay, another thing that this could be good for is because we'll be looking at some kind of post-optimality questions. One of the examples that we'll be looking at is you have an LP like this. Well, okay, maybe it's much bigger. And then after you solved it, you want to add a new constraint for either for the reasons that you realize that something is missing in your formulation, or for some other reason, which we will see then in the next term. So you want to add another constraint. Now, what you go back to the original one, add the constraint, and do the pivoting again. But it's going to take you a lot of work. Even if you're a computer, it's going to take you a lot of work. So what you want to do instead is, and because if you just add one additional constraint to a million other constraints or 100,000 other constraints or something like that, then you're probably expecting the optimal solution to be quite close to what it was before. Okay? And so what we want to be able to do is just look at the final tableau and know what kind of constraint we need to add, what kind of row we need to add to that tableau without doing all the pivoting. That's one example of things that we want to learn. And in order to be able to do these things, we need to know what the simplex tableau looks like. That's what half of it we did last week. We know what to do for this part, and the objective row we didn't finish, so that's the plan for today. Okay, so after this chatty introduction, question B asks you to do exactly what I've just said. Namely, if you know the optimal basis, you want to know how to get this tableau without any pivoting. So again, as I said, the objective row we can't do yet, but the top we should be able to do. And from what we did last week, we should know that if the basis is B, then, and these are the slack variables, and these are the decision variables, and this is the null, then we said that this was what we call MB inverse. Okay. This is what we called MB inverse times A, and this was what we called, this was what we called MB inverse times little b. Okay? We somehow derived this, didn't we? We did. Except I'm not telling you what MB inverse is. So in our question, when you look at this, this part here gives you the matrix A. Showing, yeah, good. So A is 2, 1, 3, 5. Those are the numbers appearing there. The right-hand side give you the little b. Now A and the identity put next to each other is what we call M. So this is 2, 1, 3, 5, 1, 0, 0, 1. Okay. And the columns are indexed by x1, x2, s1, s2. So this is just like in the simplex tableau that you would write to start the pivoting with in the first instance. Has anybody actually got this far in the question? No. You think if you keep ignoring these homework questions, you're going to pass the exam, but that might be. Okay, so in this case, the basis, as we've just said, is x1 and x2 in this order. Yeah, because that's what I'm saying here. X1, x2. So what is the matrix MB going to look like? What's this MB mean?
Is it just going to be that matrix that we solved in part
No, that's not what it's going to be. That's what the inverse is going to be. But okay, so I mean, this is a silly example. I know it's a good one. Okay, so MB, this notation means you look at B, and that's x1, x2, and you take the corresponding columns from M. Okay, so you take the x1 column and the x2 column. So in this case, you only get A, nothing else than A. But it's not always going to be A. In this case, it happens to be 1. So I'm taking the x1 column from M and the x2 column from M, because the basis is x1, x2. And now, looking at this, what do I need? I need MB inverse. Okay, so how do I get the inverse of MB? Well, ask MATLAB or something like that, or do it by hand. You learned that in linear algebra in the first year. Hopefully everyone could do, probably A-levels as well. Okay, so you can do the inverse. In this case, the inverse turns out to be nasty. So 5/7 minus 1/7 minus 3/7 and 2/7. I could actually copy it. Okay. So this is what MB inverse is. Well, in fact, because MB inverse happens to be A in this particular example, this happens to be A inverse. Okay. And so that means that if I do MB inverse times A, that's like A inverse times A. I can't get anything else than the 2x2 identity matrix. Yeah. Or you can do it directly if you want. You can multiply this with this. And what else does it want me to do? Okay, this column wants me to do MB inverse. Sorry, it's good. MB inverse times little b were the right hand side. So the right hand sides were 5 and 11 in the original problem. Look at the top of the sheet. Yeah, 5, 11. So if I'm doing MB inverse times B, this is going to be this matrix times 511, and when you work it out, you're going to get to 1. Okay, everything worked nicely. That was the point of last week, to be able to do this. One of the things that we want to know. Now, of course, what we didn't do, what you can't have done, is the objective row. Well, you could have done if you read the book in advance, but so this is the plan for today, to try and finish the analysis for the objective row, which we skipped. So this to 1, I'll probably saying too much, this to 1, so obviously this to 1, this identity is this identity, and this MB inverse is this bit. Any questions about the homework? No. So if you've solved part A, you can put 1 mark, and if you solve both parts, you can put 2 marks into the register. Thank you. So this is where we finished last week. We stopped. Okay, how did we, in fact, find this? How did we get here? Oh, well, the reason we got here was the previous thing. Okay? What we said was, we're starting from the original simplex tableau, that was this M, and the right-hand side's B. And then we were doing some elementary row operations. Does everybody that ring a bell? Kind of, yeah? So we expressed each of these row operations as multiplying the whole system with a matrix from the left. And we have these matrices. So for example, when we wanted to divide the second row by 4, that was the matrix we used. When we wanted to do some multiples of the second row added to what was subtracted from the first row to the third row. Okay, pretty happy about this. Now, what happens in the objective row? So now, so when you recall from 2 weeks ago, we said the original simplex tableau looks like this, except we were used to writing this row at the bottom. So we have 0 in the table. But what corresponds to the objective row is that we have this 1 minus C 0, and we times it by Z X S, and we get 0 and B. Yeah, that was the initial objective row. So what does that mean? That is just one simple equation in these variables. In Z, all the x's, so this is a vector of x's and this is a vector of s's on the slack variables. This is a vector of zeros, as many as the slack variables, and this is a vector of the coefficients of the objective function, and this is a 1. Okay? Does it make sense? Okay. Am I doing it too slowly or too fast? Everybody's sleeping and it's noon, so everybody has the right to be sleepy. It's challenging. Okay, so this is what we have. No, what am I doing? This is not what we have. What's the problem? Yeah.
Altered at the correct solution, but came out the same elements.
They won't be the same ones, but yes, you're right, but you're ahead. But this is wrong, and this is wrong because from this, I just want to take the top row, so I also have to take the top row on the right-hand side. So actually what I need here is not this vector, it's just a 0. Like this. Okay? So what happens to this row is that I keep taking some. So what do I do when I pivot? Okay, what do I do when I do a pivot step? When you think about it, whereas go back to here. So how do I go from this objective row to this objective row? Now I've done this bit, say. Now I want to know what the objective row is. So the pivot element was this one. So what I'm doing is I'm taking a multiple of this row, namely 1 over 5 times this row, and I'm adding it to the objective row. Okay. So what I'm doing is this is kind of hard, so this is okay. So suppose, what does a pivot step? So what do I have? So I have now I've done my pivot step at the top. Okay, so I have something here, which is the new B. So there is something here. New B. There is the new A after pivoting, so let's call it A dash. And there's the new identity, well, whatever, new something dash. Okay. And now when I'm doing the pivot step is I'm taking the original row that I have here. So the new so what was the original objective row? It was 1 minus C 0, except it's coming in the wrong order. So okay, so this is the 0, this is the minus C. Here there's a Z where there's the 1. times, and this was supposed to be 0, and this is this 0. Does it make sense? This is this red 0, this is this red 0, this one is green. That's actually a vector. It has to be, there are as many zeros here as there are flat variables. What do I do with it? I take a multiple of a row. How do I get a multiple of a row? So I do need to express it as some sort of vector times the top. Okay, so what I'm going to do is, so this is the old actually, and the new is this. I take, there's plenty of zeros. Somewhere here there's some number n, no, okay, and there's plenty of zeros, times all zeros, new dash, new nasty thing dash, plus what it was before. This whole thing times by zxs equals, and I do the same on the right hand side. So I do lots of zeros, k, lots of zeros, times new b dash plus 0. Okay, this is a mess. So don't, okay, this is a mess, is it? Yeah?
I don't understand the format of the table.
You don't understand what exactly?
The format.
Which one, the top and or the bottom? Well, I've done two. This one or that one?
Table back.
This one. Oh, you don't understand it?
The format.
Okay. So there's some basis, yeah? I don't care what it is. There's some objective rho, okay? This is the val, this is the x's, all the x's, x1, xn. These are all the s's. Okay, we don't write the objective, so forget it. Now, after pivoting, after I've done the pivot on the top, I get something new here. I don't care what it is, I just want to call it something. Okay. I get something new here, I don't care what it is, but I just want to call it something. And I get new this, and I don't care what it is, we want to call it something. Is that now? Okay, so this.
I did that last bit at the end as well. It's what I said, and then you have the objective.
Yeah, okay. So this is the bit we don't write, which is actually kind of implicit there, but and it never changes. So the reason we don't write it is because it's always X or zeros and one at the bottom. So there's it's like a, it was probably a false economy, because if I had kept it there from the start, then we would know what goes on better than this. But, the reason we don't write it is because it never changes. The second problem is that I started putting the 1 at the beginning rather than at the end. And that was because you told me to. Remember that. Let's see. The other way around, but that doesn't matter either. So if you ignore this and ignore this, you're getting is exactly this row, and the right hand side is the right hand side, which is the left hand side now. Shouldn't be too hard to work out. Okay, is that now clear? So what happens is we take the multiple of a row and add it to this row, and that's what's going to be there again. So the next pivot step, again, we're going to get something here. We take a multiple of a row from here and add it to this. Next pivot step, we do the same thing at the top. We take a multiple of a row in here, add it to this. That understood? That's how pivoting goes. If you've done it, you haven't done it, then perhaps you don't know. But, you've done a lot of it. This is how it went, didn't it? Every time doing the pivot row meant I take a multiple of one of these rows, add it to the objective. Okay? Okay. There's two people who are not confused. Okay, so that's the whole point. So if I keep doing this, is what I keep doing. Maybe I've overdone it with notation, so you can forget this notation. I don't. So what I keep doing is I keep taking the multiple of a row, add it, multiple of a row, add it, multiple of a row, add it. What do I end up with? Is the original values that I had there with some sort of multiples of the rows, which themselves are linear combinations of the rows. This is a hard step mentally. In the final tableau, the objective row is equal to the objective row of the first type tableau okay, that never changes. We never multiply that row with anything, or that's always there. But we keep adding to it. So instead of adding to it in every pivot step, what I could say is, okay, I'm going to take suitable multiples of the row above it and add them all together at once at the end. Because I've been adding multiple of this row and a multiple of this row and a multiple of this row, and these rows were changing, but they were not changing to anything at all. They were, anything arbitrary. They were only changing to linear combinations of the original rows. So when you think about it, what are the rows at the top here? Well, there's some combinations of the original rows, okay? And I just take the multiples so I can work it out backwards and see what number I need to multiply each of them with to get this, what I added to it. Okay, if you don't understand it now, that's okay. Just you need to think about it again when your mind is fresh. Okay, so what I added is a linear combination of the rows above. So therefore, what I have is, okay, this is just a label. So this first bit, what was the original value in it in the first tableau? It was 0. And the linear combination of the rows above. Okay, how do I get the linear combination of the rows above? Well, I take a row vector where I put the multiples of each row next to each other. Okay, so I'll call this row vector R times the thing above it. And the thing above it, according to what we did last week, is this. Okay, what's below X? Well, the original thing that was there is minus C. And we did the same linear combination of the things above it. So again, this same row vector R times whatever is sat above it. Okay. And what's the last bit? Well, the original values were zeros, all zeros. And again, I take the same row multiples of whatever is above it and add it there, and that's what I get. Okay. So R is a row vector, which gives me, for each row above, the multiple that I have to take and add. And this is what I get in the matrix. So the only thing that remains is what to find out what this R actually is. So how do we know what R is? So how were we doing? What is the condition for it to be a simplex tableau? You have to have zeros in where the basic variables are. Yeah, that's why we were adding these multiples, to always have zeros in the columns of the variables in the bases. So what we need to do, what we need to check is we wanted and got zeros in the basic variable columns. Yeah, that's what we always kept and preserved. And so this is going to give us what R is, because if we look, so we have this vector, okay, it's on the left, it is minus C plus R times A, and on the right, it's just R times NB inverse. So this is like a long vector, this bit. And if I only look at the ones that are in the basis, select them, I want to get 0. So this little b, it always does collecting the columns of the basic variables. So I select the columns of the basic variables, I need a 0. Now, there's something which I can't remember. Oh. For this, I need to rewrite somehow. This bit in the middle is minus C0. Well, that's exactly what we actually, how we got it, plus R times, sorry, no, R times MB inverse times A identity. Okay, because that's what it is. So this times the identity, you get this, and if you do this times A, you get this, and if you add zeros, you get this. Except we're only looking at the basic columns of this, we get 0. Now this here, we call M. So now this tells me minus C0. From this vector, I only select the columns that correspond to the basic variables. Okay. And from this matrix, I only select the columns that correspond to the basic variables. And again, this is the same trick we did last week. We don't have to do this multiplication first and then select the columns. What we can do is select the columns here and then do the multiplication. Okay? And so this is equal to 0. Okay, what's this? I? Or R, did you say? Yeah, that's I. So R times I is R. This is nothing, but we're going to call it minus C dash little b. Okay, so this is the definition. Minus little c with a dash, with a little b. It's going to be take the objective values for the basic variables and 0 for the slack variables, and then select the ones that correspond to not the decision variables, and select the ones that correspond to the basic ones. Plus R is equal to 0. Well, so this gives us that R is nothing else than this. Oof, this is tiring. Because it's a lot of calculations, and it's not really obvious where it's going to. But we've gone through all the detailed calculations now, and the rest is going to be much easier for the rest of the year. Okay. So this gives us what we needed. So this gives us that the objective row, well, it's up here. The objective row looks like this, and now we know what R is, so we can conclude what the objective row is. And just to label, this one is I'm just copying from the thing that's hiding just above here. Okay, I'm replacing R with well, we know what it is now. So that gives me the whole tableau, which is theorem 4.7 in the book. Okay, so when I know what the basis is, it doesn't have to be the optimal one. It can be any basis you can think of. I can, without any pivoting whatsoever, can find what the tableau is going to look like. Yeah. Now you know enough to finish last week's homework. It's very little effort. Once you understand how it goes. And if you don't quite understand how to go from an example to the Tableau, there is a whole section called 4.3, which tells you exactly, if I tell you what the basis is, and I tell you the original one, how do I get directly the right simplex Tableau without any pivoting? So go through that, read it, make sure you understand it, and come back with any questions either on Friday or next week. So we can have a look at it. Anything particular, course, moment, right? Good.